Hi there. So today we're going to be looking at classes in JavaScript. Um, so there's two parts about it. There's the first part, which pretty much we'll be using, what is this? The developermozilla.org website, which has good content about JavaScript. I tried to look into, what is this, W3 schools about classes. And it does good, but honestly, I prefer what is this? The developer.mozilla.org website. I think it does good for me in explaining more content. Um, so we're going to be learning about using classes today. Pretty much, we're going to be reading this and talking about it. That's pretty much what we're going to be doing. I've warmed up my fan, so my piece is a bit loud, which is fine. So what do we learn about using classes? JavaScript is a prototype-based language. So that's the first thing that we learn. An object's behavior specifically by its own prototypes. An object's behavior are specified by its own properties and its properties and its prototypes properties. If I need to zoom in a bit more, it's a little wrong. However, with the addition of classes, I think we know what a class is essentially. Classes are templates. That's pretty much what we know they are. But then obviously I want to create a good class, and my class should be able to read from my database in a very good way. Pretty much the purpose of this is that I want to write a select statement. Obviously, the first thing that I did is that my database, I make sure that I don't, when somebody wants to interact with my database, they don't write select statements. That's what I did. But then they only call methods. That's pretty much what happens on the database end. And so I want to do the same here. But then this time, I don't want to write call. I want to create a class that only takes parameters. And you should know what you want to do. If you want to update a person, you just call the class and you'll update the person. If you want to create a person or a customer or whatever thing that you just use the class and you don't even have to use the database. So that's what I want to do right now. That's my intention of doing this. And obviously from C++, I understand the structure of classes from C++, but then I don't really know how it works. So right now we're on the overview. We'll be learning about declaring a class, constructors, instance methods, private fields, accessor fields, public fields, static property types, and then that's pretty much what we'll be learning about throughout here. Okay, cool. Let's see. In many other languages, classes or constructors are clearly distinguished from objects or instances. In JavaScript, classes are mainly an abstraction over the existing prototypical inheritance mechanism. Okay, that's some deep English there. I didn't really understand this, but I'm going to move on. All patterns are convertible prototype-based inheritance. Okay, the classes themselves are normal JavaScript values as well, and have their own prototype chains. In fact, most plain JavaScript functions can be used as constructors. You use the new operator with a constructor function to create a new object. Okay. We'll be playing with the world-based abstracted class model in this tutorial and discuss what semantic classes offer. If you want to dive deep into the underlying prototype systems, you can read the inheritance and prototype chain guide. Okay, I won't read it for now because I don't want to jump over places. I just want to focus on classes, and then when I have questions, I'll ask them later. This chapter assumes that you are already somewhat familiar with JavaScript, and that you have ordinary objects. Overview of classes. If you have some hands-on experience with JavaScript or have followed along with the guide, you probably have already used classes. If you haven't created one, for example, this may seem familiar to you. So I see what the first thing that they do here is that they create a constant, and they say it's a big day. And obviously from big day, well, as much as a constant, they use a date class. And I assume there's a constructor here that takes default variables and then creates a new instance of big day. And the new instance will obviously be populated with these values here. So if you say to local date string, I assume that I don't know what this thing does, but I'm not going to search it for now for the sake of time. Now, on the first line, we create an instance of the class and call it big day. Okay. On the second line, we create a method to locate day string on the big day instance, which returns a string. When then we compare the two numbers, one returned from the getTime method, the other directly called from the date class itself, as date now. Date is a built-in class of JavaScript. From this example, we can get some basic ideas of what classes do. Classes create objects through the new operator. Okay, classes creates object through new. Since we talked about a template and we talked about a framework, right? A framework is like okay, we know what a framework is and a template is, but I'm thinking how in this case here. Well, yeah, no, I think I'll be sophisticating it more if I try to. But I think it makes sense. Classes creates objects through the new operator. Good. Each object has some properties added by the class. Okay. The class stores some properties itself, which are usually used to interact with instances. The class stores some properties, data or method itself. Okay, I get what that means. This corresponds to the three key features of classes. A class, okay, a class has to be a constructor, instance methods and instant fields, static methods and static fields. So I guess this is what makes a class. So three key features of classes. I guess if it has a constructor, then it's a class. If there's instances and methods, fields, if there's instance, method, fields, methods, and instant fields, then it's a class. Okay, so let's see how do we declare a class. So let me come to my code here. Okay. Okay, cool. So the first thing that I see to declare a class, one starts by using the keyword class, then giving it a name. Cool. I guess that's the step to declaring a class. You write class, then you give it a name. Obviously, it's enclosed in the body is enclosed in curly braces. Within a class body, there are a range of features available. Okay, let's see the features available. So the first feature is a constructor. So I'm going to do this. I need this, so I don't want to move them out now. So I'm just going to keep them here. So the first feature is a constructor. What's the next feature? And we have also the second feature. We have instance field. Then we have instant methods. So those are some of the things that we have within class. And also we have static fields. Okay. Static fields. Okay, what else? And then we also have static methods. I wonder what's the difference between these. We have a static block. Okay, I don't know what a static block is. Okay, cool. And then we have fields, methods, static fields, and static methods all have private forms. Okay? All have private forms. My private field. Okay. We'll get to that as well. Hopefully they explain all of them one by one. Okay, but I think I see here extends with inheritance. If he came from the pre-E6 world, he may be more familiar with using functions as constructors. The pattern above would roughly translate to the following with functions and constructors. Function, my class, this, my field, is equal to foo. Okay, that's a constructor. But then with my class, let's see, my class static field is equal to bar. Okay. But then if it's static, there's something, I forgot the meaning of a static variable. we have a constant variable, and then we have a static variable. I just forgot what a static variable is, but we'll get to it. So I see here we have a static variable, and then it is assigned my bar, and then we have static method is equal to function. And then here we define the new function, my method, my class, prototype. My method is equal to function, then function. Okay, I don't know, this is just a function out there by itself. Constructing a class. If the class has been declared, you can create instances of it using the new operator. Okay, cool. So we see what the new operator does is that it creates instances of the class using the new operator. Typical function constructors can both be constructed with new and called with new. However, attempting to call a class without new will result in an error. Okay, I guess I see the type error here. Class declaration hoisting. Like function declaration, class declarations are not hoisted. What does it mean, hoisted? Or in some interpretation, hoisted but with different temporal. What does the word hoisted mean? Hoisting. JavaScript hoisting refers to the process whereby the interpreter appears to move declaration of functions, variables, classes, or inputs to the top of their scope prior to execution of the code. Okay. Unlike function declaration, class declarations are not hoisted. Okay, which means you cannot use a class before it is declared. Okay, I understand this. Okay, so for example, if we say my new class reference error cannot access my new class before initialization, so I guess it means it goes what is this, synchronous. It needs to start from the top to the bottom. I guess I don't know why they call it hoisting, but I guess it's a brand new term. I don't know if it has an English. I don't know the meaning of hoisting. Hoist, raise something by means of rope or pulleys, raise up. Why is that such a complex term though? Okay. Raise something up. Okay, I guess I see. Oh, wow. Right, that's a very intelligent term. So to raise something up means that if I create a class or whatever, then this class here is hoisted up. Maybe that's what the compiler does, according to what we came to learn from the previous verses. Is that if you create all these things, the interpreter appears to move the declaration of functions prior to the execution of the code. So, which means the compiler, what it does is that it takes, what's that example? Nope. Yeah, I think we're here. Okay, I think we're done. Where are we? Okay, cool. So, for example, what the compiler does, or the interpreter, according to the use of the word here, it'll take this class definition here, and then it'll move it up here below the declaration, so that whenever a declaration is called, the class is obviously declared first. This behavior is similar to variables declared with let and const. Okay, class expressions similar to functions. Class declarations also have their expression counterparts. Okay. Okay, so that means I can. What does this mean, though? Class expressions can have their names as well. This expression's name is only visible to class body. What does this expression mean? I see this const, my class is equal to class. Now, what I'm understanding is that this is not then a what is this? I understand it's a shorthand way of writing a function. So instead of defining a function that we're going to use later on, this is obviously, I forgot the term as well, but then what I understand is that this is a shorthand way of writing a class. I can write a class this way, but that means once this variable here is done being used, we cannot call the class again because the class is defined in this variable here. Okay, constant my class is equal to my class. Okay. Reference error, my class name is not defined because it is in here. Okay, See constructor. Perhaps the most important job of a class is to act as a factory for objects. For example, when we use the date constructor, we expect it to give a new date object, which represents the data we passed in, which we can then manipulate with other methods. The instance exposes. In classes, the instant creation is done by the constructor. In classes, the instance creation is done by the constructor. Okay, I see that. As an example, we would create a class called color, which represents a specific color. Users create color through passing the RGB triplet. Okay, so I see we have something like this color, and then the constructor takes in these values, and then the values will obviously be populated here inside the values array. Okay, so now I have my values here. So then that means what I can do is I can take these values and okay, let's see how we're going to make this work. Okay, I can take these values and then obviously I can create this tour guide. And then I'll do it this way. And the first thing that I'm going to do, what I can find within this, I just want to find these and then replace them with do it this way. And define equal to these two and this, and I want to replace it with that. Cool. So the first thing that it needs is that it needs a constructor. Let's take a constructor. Okay, so it needs a constructor. So now making use of this constructor, then obviously I need to create space. I can remove this. Thank you very much. Then I can add these here. So now oops, how did I not see you? Oh, you didn't have that. Sneaky. Okay, cool. So then obviously we have a constructor. This constructor takes a tour guide variable, and then using the tour guide variable, then obviously I'm able to do all of these here. Tour guide variable, no, that's kind of tricky because obviously the tour guide variable, I want this thing to be a JSON object. And if it's a JSON object, then that means I need to add tour guide everywhere, because it'll obviously be like that. Oh, okay, this won't work. This won't work. I need to add them here. Okay. Now I can find, and then I can say it's tour guide everywhere. Thank you very much. Then I can just start to add this now. Now, instead of doing it this way, can I create something like new address, email verified. Okay, access token. Then we have a refresh token. Open ID. Number. Janet. Phone number code. Rating. Oops. Row. Okay, cool. And now, okay, so that's what we have right now. So I'm getting this tour guide. I'm getting this tour guide object. I'm passing it into the constructor. That it will have to know that it needs to take all this. But then also, what if this is empty? If it's empty, I want it to say, look, I'm empty. So that I don't have to go around doing all this for an empty thing. So let's see what happens from there. Okay, cool. So now that's the constructor. The constructor always takes this. And it makes sense why it should take this, because ultimately we want to add data into this template and then start to use it. Does it make sense? In other words, we have a car. We need to know the driver of the car. So the data in this case is like the driver of the car. If Chico comes in, Chico is the driver. So it cannot operate without a driver. So it makes sense why it has a constructor. I understand with some other things, with some other programming languages, a constructor fine may be used, but then it may take empty things. So now we'll see about fields and so on. So let's see from the next thing. Oh, I remember. Okay. Go to your browser's DevTools, paste the above code into the console, and then create an instance. Okay, cons red is equal to that color, then console reg. We should see some output like this. Object output, okay, I see that. You've successfully created a color instance, and then that instance, okay, so that means we should also have created something good then. I'm just gonna come here and create this. I'm just gonna create a new variable. I'm gonna call it a tour guide. Tour guide is equal to just random number, random characters. Okay. First name, Kong James. Last name, Livingston. Okay, cool. Others are fine, they'll just be null for now. Then I can then say var tour guide is equal to new tour guide. And then here I'm just gonna put my tour guide. So that means if I just console log, okay, well these are the same thing. Just say data. Now we have a tour guide. So then I can just say console log tour guide. That means if I console log this, okay. Index. Okay, cool. Now we see we have something similar to that. We have tour guide here, and this is the, what is this? The JSON object that we have. The first thing that we have is the username. Why do we have username? And then these. Okay, username. Okay, I see where the problem also went wrong. I see where the problem is. The problem is that the username I said is tour guide, but rather I should put here username. Okay, not index. So now we can see we have a tour guide. Pretty much, I'll say we have a tour guide variable, which is of type JSON, and then we have username, which is that, first name James, last name Livingston. So that's pretty much what we have here. I'm just gonna close it for now. Okay, cool. So let's see what's next that we can learn about So now we've successfully created a new instance. The instance that we created is this one. The tour guide instance is it's derived from this class here, and we've obviously populated the constructor. Okay. The constructor syntax is exactly the same as a normal function, which means you can use other syntaxes like rest parameters. What are these rest parameters? Okay. Okay, I think I understand. Each time you call new, a different instance is created. Okay, I get that. Within a class constructor, the value of this points to the newly created instance. This you can assign this property to it or read existing properties, especially methods, which we will cover next. Okay. Now understand what this does. Remember how we made an example of a car, that if you drive a car, we need to know who the driver of the car is. So the with this, it pretty much points to the driver of the car. That's pretty much what it says. Each and every single driver of the car will have different names and so on and so on and so on. So if I say this, then it knows. If James Livingston is the one driving the car, this James Livingston, this points to James Livingston. If Shigo is the one, this points to Shigo. Okay, cool. Let's see. Okay. Instant methods. If a class only has a constructor, it is not much different from a create X factory function, which just creates plain objects. However, the power of classes is that they can be used as templates, which automatically assigns methods of instances. For example, for date instance, you can use a range of methods to get different information from a single date value, such as year. Okay. You can also set those values through the set X counterparts like set full year. Okay, cool. Now let's start by this now. Now let's get individual items now. So we have a user. Let's create a function that gets a user. Okay, so it's gonna be a function. It appears that I don't have to specify that it's a function. I just write get, and then it will know that it's a function. Okay, so to get, then I don't have to really specify anything else, right? I just need to know the ID of that individual, then I'll obviously retrieve the user. Okay, right? I'll say username. Well, but then at this point, now I remember what static methods are. Static methods are pretty much global. Each and every single class will have that value. That's what static methods are. And if you fix it here, our static functions, static variables, if you change the variable, each and every single class will contain that variable. And let's say by that time, we'll have a static array of all the users that we've created. Doing that now. Okay, we just want to return this. All right. We just want to return this here. Let us do the test. Now, the nice thing about JavaScript is even if we miss that thing, is it shouldn't really give us a problem. Let's see if it won't give us a problem indeed. Okay, but it seems like we only have one of them. Well, we got it, but we didn't display it. Oh, we did console log it. That's the get tour guide. Okay, cool. So we can see we have get tour guide. Get tour guide is this function here which gets this person. So yeah, I think it's quite fair in a way. I say so. Yeah, I think it's quite fair. So the next thing that I then need to do, obviously, I have get, then I need to have my setters. Now, the interesting thing about setters is that I can set multiple things at the same time. I can set one thing at the same time. That's what I think I can do. Okay, let's see. Okay, I'm back. We did a get read, but then we obviously got our own thing that we wanted to get. So without methods, you can be tempted to define. Without methods, you may be tempted to define the function with the construct within the constructor. Okay. Oh, interesting, I guess. Okay. So then that means we can have a constructor, and then what is this? How does this even work? Let's see. Console log new color dot get new color false. I'm lost. Okay. This also works. This also works. However, the problem is that this creates a new function every time a color instance is created, even when they all do the same thing. Okay, I get that. I understand. So then, the interesting thing about obviously having this function here is that each and every single class will share the same function. Hence, we use this operator to help us know who's driving that class for that moment, and address them pretty much reference to that person or reference to that instance. This works well. Okay, we read this in constructs. In construct, if you use a method, it will be shared between all instances. I think this is what we just talked about. Function can be shared between all instances, but still have its behavior different when different instances call it, because the value of this is different. We talked about that. If you are curious where this method is stored, it's defined on the prototype of all instances of color prototype, which is explained in detail in the inheritance prototype chain. Okay. Similarly, we can create a new method called setRed, which sets the red value of color. Okay. So now let's create a set method here. So here we're going to talk. So now let's create set target. Now I'm also going to pass in a variable here. Oh, here we got a target now. Here we're setting a target. So I'm just going to say target. And then I'll just say this. Okay, we'll see. And then let's return it when we're done. Okay. We'll see what it does. I think what I'll do, I don't know if it's going to erase everything. And then, for example, if I only pass in my username, if it's going to erase anything and only give us the username, or if we'll have all these other attributes in there as well. Okay. Set. Then, just so that I can understand more, I'm just going to say username. That's the username. Let's run this and see what's going to happen. Okay, cool. So what it did here, the set talk guide, it took everything that I see. It cleared everything out, removed all this, and then it only returned. Since we were only setting the username, it only set the username. Everything else, it marked it as it's pretty much not there. But then is there a way that we can do this well? So then if we want to do this well, then it means we have to copy all of this here and then paste it there again, and then set them one by one like we did on the constructor. Okay. Let's see what's next. Const red is equals to new color. Const red is equals to new color. Okay, red. Okay, we just did that. Private fields. So now what are private fields? You might be wondering, why do we want to go through the trouble of using getRed and setRed methods when we can directly access the values array on the instance? Okay, and let's show us how we can access them. There's a philosophy in object-oriented programming called encapsulation. This means that you should not access the underlying implementation of an object, but instead use well-abstracted methods to interact with it. For example, if we suddenly decide to represent colors as HSL instead. What is HSL? What is HSL? Okay. I want to go through it right now. HSL instead. The user assumption that value means the RGB value suddenly collapses, and it may cause the logic to break. So if you are an implementer of a class, you would want to hide the internal data structure. If your instance from your user, both to keep the API clean and prevent users' code from breaking. Okay, I guess that's where it's the installation comes. That is not the installation. Encapsulation. Now, how do we do it? A private field is an identifier prefix with this. Okay. The hash is an integral part of the field's name, which means a private property can never have class name clash with public property. In order to refer to a private field anywhere in the class, you must declare it in the body. You can't create a private on the fly. As part of this, a private field is pretty much equivalent to a normal property, proper E. Okay, so then what I can do to do this, so now what then I can do is I can make all these here private fields. Okay, just gonna copy this. And then I'm gonna call this private fields. Okay. Okay, cool. So now I can just start to move some of these. All right. Okay, that's right. So I think maybe the problem that I was doing initially is that I added the word const or var, which doesn't allow. So now to make all these private fields, meaning I don't want anybody, a user, to access them without making use of a function, I'm just going to put a pound hash. Then it says now these public are private. It's declared, but it's never read. Okay, good. So now, if that is the case, then all that I just need to do is just to do that. You also need to put this here. Let's see. Oh, okay, cool. I do need to put this. Okay, so that means I can just do that. You can do that. And if that's the case, then everywhere I just need to put it this. Okay, cool. And then now I need to replace the colon with an equal sign. And it should be eyes. I just need to remove this guy here. Okay, well, that's a constructor, so good. This is what we have now. We remove this thing and made everything now an individual attribute, attribute of thing. So now I can access these things individually without having to use a tour guide. So now where it also gets interesting is that with all of these things accessible, it also means that I then need to create a function to access each and every single one of them until I can be able to make use of them. So now let's see how I'm going to make use of that. Okay. Okay, cool. So now that's our private fields. I want them to be accessible. And then I'm going to call this our construct method. Good. Okay, let's see. Sorry for changing you guys as well. I didn't mean to. Okay. Okay, good. So that's what we have here. Okay. Now, let's see what's going to happen now. Okay, let's see. So what we did is the username is used here on create tour guide, but then we create a brand new variable. That's what we did here. I guess that's how variables are created, I guess. Because the wait var is not needed. So this means it's a brand new variable that we created. Yeah, that's private fields. Okay, cool. So now we know how to declare a private field. Accessing private fields outside the class is an early syntax error. The language can guard against this because private field is a special syntax, so it can do some static analysis and find all usage of private fields before even evaluating the code. So let's see. That's dope. We do have first name. We shouldn't have first name. Oh, sorry. I did a mistake there. Okay. Yeah, well, that means I'm only putting first name in there. So that means I can't do that. It doesn't allow it to happen. Note, code run in Chrome console can access private properties outside the class. This is a DevTools only relaxation of the JavaScript 6 syntax restriction. Okay, private fields in JavaScript are hard private. If the class does not implement methods that expose these private fields, there's absolutely no mechanism to retrieve them from outside the class. This means you are safe to do any refactors to your class's private fields, so long as the behavior of exposure methods stay the same. After we've made the values field private, we can add some more logic to the getRed methods instead of making them simple pass-through methods. For example, we can check the validity, and I think that's the power of it for now. Now, for example, we know that a first name cannot be what is this? What are these things? A user first name cannot be what is this? What do we call this? It cannot be a number, for instance. It cannot be a number. So then we can set a new function. Say set first name, which takes what? First name. Then you can say if first name is a number, then reject it. Now I need to check the thing that makes it work that way. Okay, check if variable contains a number in JavaScript. Okay, so there's another thing that says it's none. The snap building function is used to check if value is not a number. Update Christopher is right. In JavaScript, Boolean types are convertible to numbers returned 1 for true, and +1 will result to true. Considering this value, I've updated the function to prevent converting Boolean values to its numeric. Okay, so let's see. Check if variable contains a numeric value in JavaScript. Return type of n is equals to Boolean. Okay, well, there is a way to do it. Okay, let's check here. Tennis name has I know there's a test. Okay, let's see what does the name mean. Let's just start by returning this. First name. Let's see. Then we can just call it console the clock. Target. Set first name. I can just add a random number here. Okay, so this is false. It's not a number. True, well, it's not a number. Okay, let's say it's not a number, should return true. So yes, RSJD is not a number. Let's see if we put 1, what it's gonna say. Okay, it says false. This is a number. It says false. This. The first one was set false because we entered obviously characters. Second one says false because we entered number. Second one said false because we entered as a number. So ultimately what it's saying is this number is not a number, which then evaluates to if evaluates to false if it is a number. So, and evaluates to true if it is a number. Okay. First name. So then we can then say something like if what is this? First name is not a number. Which is this? We need to put a not here because we say this is not a number. True is not a number. Not a number. Then yeah, you get the point. Then if that is the case, then we can simply update this first name with first name. And we can obviously keep on adding these things as much as we like. And also we can even add some things. We can check the case of the string. For example, what if somebody uppercase and lowercase is all over? So then we can create a way of maybe we can let's see if we can change the case. Okay, let's see. Okay. So cool. We can just say text is uppercase. That's what we can do here. Hello world. Oh, I just added the D, so if I put it that way. So then I can make, but then I only want to make one. Oh, that should give me an error. I guess it's not giving me an error. Okay, cool. Let's see to locate these. And what's the difference with text to locate uppercase and the other one? So make character uppercase script. Okay, so let's see. Oh, this one says chat. I hope it's not. What is this? Okay, I see what I can do. But then it's also quite tricky as well, because what if maybe your name has something like the cock, where it has a prefix or something. So anyway, you get the point. So we can play around with that and not use the point that I want to be in. Okay. Yeah, we were here. We can also check other things as well. We can restrict things. If we leave the value property exposed, our users can easily circumvent that check by assigning two values at index 0 directly and creating valid errors, but with a well-encapsulated API. We can make our code more robust and prevent logic errors downstream. A class method can read the private fields of the instances as long as they belong to the same class. Okay, let's see. So we have a class color, which does all these things. Return. Okay, I think I'll just stop here. Okay. Cheers, everyone. Bye.